Hi again, my name is Matt and this is the fourth video of my C++ beginner's guide on YouTube, and in this video we're going to be learning how to create and use variables inside our C++ code. Just a note before we start the video, I just want to say that I decided to upload all the code that I'm writing in these videos to a GitHub repository, which is basically a place where you can push your code so other people can access it. So if you guys feel the need to look at the code that I've written so you can have an exact comparison between what you've wrote and what I've written, you can go to this website that will be on the description, and to download everything that I've pushed so far, everything that I've uploaded so far, you can click on code and download the zip. Feel free to actually use the GitHub functionality, so use your Git program to actually download the code if you know what it is. But if you don't have Git, don't worry too much, just click on download zip and you have all the source files that we have created in this video guide. So let's get to it, shall we? So the first thing you're going to do is you're going to open your IDE of choice. In my case, I've got Visual Studio open here. And you're also going to create a simple C++ project with CMake. So in my case, I've got a simple CMake list here and a simple source code, variables or CPP, where I'm going to be putting all the code that we're going to be writing in this video. If you don't know what these things are, if you don't know how to create the structure, please watch my earlier videos, especially the second and third video. I explain very well how to create a very simple C++ project and what each of these lines mean in C++ and why you need them. Now, just to give you a quick run through of what we started with here is, on the first line of C++, I've got an include directive here. So I'm including IOStream, so I can essentially use the std_cout functionality to output text to my console window. And I've also got a function main defined, and inside the main I have std_cout, and the title of the program I put it as creating variables with some equal spaces here. So basically when you run the program, it just prints out something nice so we know, so we know what we're working with, which is creating variables. Okay, so that's all I've done so far, and now we're going to continue to actually explain how to create variables and use variables. If you don't know what variables are, you can think of them as pretty much boxes where you can put values in to be stored or to be used later in your program depending on what you want to do with it. In C++, these boxes or variables, they always have a type associated with it. So you always tell C++ what type of values you want to store in your box. For example, if you want to store an integer value, a whole number value, you'd say, I want an int variable, and then you give it a name. I just want to say that variables are pretty much a fundamental part to any programming language because they provide you with a way to request space from your RAM memory so that you can use the space to store values in your program so you can use those later. But most importantly, variables provide you with a way to name values in your program. For example, if you have a value number 4 in your program, what does it actually mean? Is it someone's age or is it the number of cars that they have? With a variable, you can name exactly what the value means. So let's actually begin creating and using variables in our program. Now, in C++, there are two stages to creating a variable. The first one is called a declaration, and the second one is called a definition. Now, a declaration is a line of code that declares a variable in your program. In other words, you're just saying that you want a type of box to store a type of value, okay? And this is what a declaration will do. So if you do something like this, you're essentially telling C++ that you want to create a variable called myValue, which always stores integer values, so int, this is what it stands for, and it's followed by a semicolon. Every line in C++ is followed by a semicolon. This means an end of statement. Now, int is the type of the variable, and it must be here. You must provide a type to a variable. There are many built-in types, but today we're only going to be talking about int, and in future videos I'm going to be talking about other number types that you can use, as well as some more complex types. So we've got the type here, and it is succeeded by the name of the variable. And if you're just declaring the variable, you put a semicolon after it. Now note that this doesn't actually give myValue a value. And to do that, you must write the definition of this variable. Now, you could write this in a separate line. So you could say myValue is now equals to 10. Okay, so this first line here is a declaration of the variable, and the second line is the actual definition where you are defining a value to your variable, which in this case is called myValue. Of course, you can do all of this in the same line. So if you are declaring and defining your variable in the same place, you must do it like this. Just int myValue equals 10. And this will give your myValue variable a value of 10. Okay. Now there is another way to actually initialize this variable, which is instead of using the equal sign, we can use the parentheses. And this is actually a superior way of defining a value in C++ because it prevents something called narrowing. It prevents you from mistakenly converting other types to this type here that you declared. Okay, so for example, if I had 10.2, this wouldn't even compile. The compiler would say, hold on a second, you're trying to give my value, which should be an integer, a value of 10.2, which is not quite an integer. So let's see what happens. You see that you get an error here saying conversion from double to integer requires a narrowing conversion. And this basically means that the type that you're trying to store in your variable needs to be converted before you do so. And this type of initialization does actually prevent many errors that you may mistakenly have in your code. So I would recommend you to always use the curly braces initialization instead of these equals, because if you use the equals, this may go unnoticed. It will just work, as you can see here. So if you try to compile and run your code again, this time it will just work. Okay. Now, interestingly, what is actually the value of my value variable here? So we can actually print this value out by just writing the following line. So this line here will print the text, value of my value is, followed by space and followed by the actual value of my value, and then a new line character after that. So in this case, where we declared the variable my value and assigned it to 10, it will just say 10 on it, or that's what we expect at least. Okay. Now, interestingly enough, what happens if I just do 10.2? And just to remind you, I've declared my value to be a integer type, so it can only store integer values. Let's see what happens with the equal sign. It says value of my value is 10, and this may not be what you want exactly. So essentially what C++ does is it truncates this number, so only the integer part is visible when you assign a non-integer value, so a floating point value, decimal value, shall we say, to an integer value. It will just do exactly that. It will just truncate the floating point and just save the integer part of it. And this is why the curly braces might be exactly what you want, because it might prevent this type of bug. You see, it didn't tell you about the conversion at all in your C++ code. It just did it implicitly. But with this curly braces initialization, you'll prevent that sort of error, that sort of bug from happening in your code. That's why I say always use curly braces initializers when you can. Okay. Now, just another note, I have mentioned that you can declare a variable and assign it in a different line, just like this, yes? But what happens if you use the value of my variable before it's actually defined, before you actually gave it a value? In some compilers, I think in my case is quite different here because I've got some flags enabled, but this might compile just fine, and you might actually be able to see some bogus values being output with this line of code here. But this essentially tells your CPU the following: I want to reserve some memory in my RAM to store exactly one integer. And in your code, you're going to refer to that space in memory as my value. So you will reserve a certain number of bits to store an integer value. Usually that's 32, depends on your machine, but usually that's 32 bits. But it doesn't clear that memory beforehand. It will not clear. You will just use memory that's currently unused in your RAM, and it will let you assign values to that space in your RAM. Okay, so this line of code here is actually undefined behavior in C++ because you're actually using this value before you gave it a value in your code, before you reset the value, shall we say. So although it is possible to actually compile this code, try your best not to write this sort of stuff, because you have undefined behavior here. You have no control as to what value this my value variable is. Okay, and that's why you should always define your variable when you can in the same line as the declaration. Okay, even better, always define it with the curly braces as well if you're just starting out. This is good practice coding, and it will prevent a lot of bugs in your code. Well guys, I'm going to actually leave this video here. It's a very short one because I didn't want to overload you guys with a lot of information. I simply try to focus on just creating and using variables in your code, and I also spoke about some good practices when doing so. So in future videos, we'll use the concept of variables a lot more, and that's why this is one of the first videos in the guide that I'm making. So if you haven't quite understood this video, if you have got any more questions, please post a comment on the video and I will try to get back to you as soon as possible. Well, I'll leave this video here, and bye bye guys, until the next one.